Welcome dear students to a very exciting topic related to the metallurgy, and that is the extraction of iron from its ores. Extraction means separation. Ore is basically a naturally occurring solid rock or some mineral deposit which contains some valuable element like some valuable metal in a concentration high enough to make it economically viable for the mining and extraction. So simply saying that ore is an impure form of a metal which is obtained from the earth crust by mining, and then by using different extraction processes the pure metal is obtained from that ore. My dear students, the important ores of iron they include magnetite, Fe3O4, haematite, Fe2O3, and the hydrated form of the haematite, that is Fe2O3.3H2O. These are three important ores of the iron, and you can see that all these ores they are basically the oxides of the iron. If you want to obtain pure iron out of these oxides, you will have to remove this oxygen, and removal of oxygen is called as reduction. It means that reducing all these ores you can get the pure iron. And in this topic we are going to learn how these ores can be chemically reduced to the pure iron. My dear students, the extraction of iron, it takes place in different steps. The first step is the concentration of ore. In this step, the impurities like carbonates, moisture and sulfides, they are removed from the metal ore. And this concentration takes place by two processes. First is the calcination. Calcination is important in removing the moisture and carbonate impurities from the metal ore, and roasting, that is important in removing the sulfides from the metal ore. The calcination is carried out in the limited supply of air at relatively lower temperature, while the roasting is carried out in the excess supply of air at relatively high temperature. So both these steps they will remove three impurities from the ore. First carbonates, second sulfides, and third one is the moisture. And the removal of these three impurities from the metal ore, that is called as the concentration of the ore. Once these three impurities are removed from the metal ore, then it is called as the concentrated ore. Now, my dear students, this concentrated ore is then mixed with calcium carbonate, which is also called as calcite, and coke, which is an amorphous form of the carbon. And when these concentrated ore, calcium carbonate and coke are mixed, they are grinded into the small pieces, and this mixture containing the small pieces of the concentrated ore of iron, calcium carbonate and coke, that is fed into a special type of furnace, and it is called as the blast furnace. So the third step will be feeding this mixture to the blast furnace. My dear students, anything which is introduced into the furnace, that is called as its charge. So anything which is fed into the furnace, that is called as its charge. And in this topic, the charge of this blast furnace is the mixture of the concentrated iron ore, calcium carbonate and coke. This one is a schematic diagram of the blast furnace. It is called as blast furnace because the hot blast of air is used in this furnace. And my dear students, the blast furnace is very different from reverberatory furnace, because in blast furnace, the material to be processed, that will be in direct contact with the fuel. But in reverberatory furnace, the material to be processed is not in the direct contact with the fuel, rather it is in the contact with the combustion gases. So this is the difference between the blast furnace and reverberatory furnace. My dear students, this blast furnace is a gigantic steel tank. It is made up of steel and it is lined with the heat resistant bricks, which are called as the refractory bricks. There are different temperature zones in the blast furnace. In the upper portion of the furnace, the temperature is relatively lower, while in the lower portion of the furnace, the temperature is high. My dear students, there is an inlet through which the hot blast air is introduced. There is an outlet for the removal of the hot waste gases. Then there is an outlet from where the molten semi-solid waste called as slag is removed, and there is an outlet from which the molten pure iron will be obtained. So this one is the schematic diagram of the blast furnace, just to understand the working of this furnace. Now my dear students, let us look into the working, that how this furnace works. When this charge is introduced into this blast furnace, the charge moves from upper side to the bottom of the furnace. And the hot blast air, it moves from bottom to the upper portion of the furnace. It means that the charge flows downward and blast air flows upward. So that is called as the counter current mechanism. Counter current mechanism means the two substances they are having flow in the opposite direction. The charge will be moving downward and the gases, hot air, that will be moving upward. This counter current increases the contact surface area between the two species and that makes the reaction faster in the blast furnace. Now, my dear students, first of all, this coke present in the charge, which is basically a form of the carbon, that is partially oxidized by the air and it is converted into the carbon monoxide. So, first of all, the coke which is present in this charge, that is burned and it is partially burned into the carbon monoxide. And this burning of the coke will produce a large amount of the heat, and that large amount of the heat will maintain the high temperature in this furnace. So keep in mind that the high temperature in the furnace is not maintained by the hot blast of air, rather the high temperature in the blast furnace is maintained by the burning of this coke. And my dear students, burning of this coke will produce carbon monoxide. Carbon monoxide is a very powerful reducing agent because it is easily oxidized to carbon dioxide, so it will reduce any substance in contact with it. My dear students, in the upper portion of the furnace where the temperature is low from 500 to 900 Kelvin, these three reactions they are taking place. The iron ore is reduced by the carbon monoxide and it is changed to another ore, and the CO after oxidation, that is changed to CO2. So basically in this complete blast furnace, the chemical reduction of the iron ores takes place, and as a result of the chemical reduction of the iron ores you will get the pure molten iron. Now in the second stage, again this carbon monoxide will reduce this ore and it will convert it into the pure iron. This pure iron, because of the removal of the impurities, that will be melted, and now the molten iron that will be collected from the bottom of the blast furnace, and again the CO is oxidized to CO2. Then in the third step, this ore is again oxidized, reduced by the CO, and it is converted to the iron monoxide. My dear students, these three reactions simply include the reduction of the ores of the iron, and in the second step you can see that this pure iron is obtained. Now again in this zone, from 900 to almost 1500 up to this, from 900 to 1500 Kelvin. These reactions they are taking place. The coke that is burned with CO2 and it is converted to more carbon monoxide because carbon monoxide is required for the reduction of the metal ores. And this carbon monoxide will then reduce this iron oxide, and again the pure iron will be obtained, and this pure iron will be melted and it will be collected from this outlet. So basically, when the charge flows from top to bottom, the chemical reduction of the metal ores takes place, and as a result of the chemical reduction, the pure metal is obtained, which is collected at the bottom in the liquid state. My dear students, the iron ore will give you iron. The coke produces carbon monoxide, which is a strong reducing agent, and it chemically reduces the iron ores into the pure iron. What is the function of this calcium carbonate? My dear students, in this blast furnace, the calcium carbonate is thermally decomposed, and after decomposition, calcium oxide and CO2 is obtained. This CO2, that is basically the waste gas of this blast furnace, and the CO2 will get removed from this blast furnace through this outlet. And my dear students, now this calcium oxide reacts with the silicon impurities present in the iron ores, and that will make calcium silicate, that is slag. Slag means semi-solid waste material of the furnace. So this slag will be removed from this outlet. Slag is a waste material of the furnace, but sometimes slag is very useful for the other industrial processes. Just like in this case, this calcium silicate, it is a slag, it is a semi-solid waste of the blast furnace, but this calcium silicate can be used in the glass industry for the manufacturing of the glass. So slag is the waste of furnace. It is not anything like useless that you can throw it just like that. So slag is sometimes used in some other industries. Now, my dear students, after all that happening, after this complete process, the molten iron that will be obtained from this blast furnace, that will be containing 3 to 4% carbon and very, very small amount of the impurities like sulfur and silicon. And that form of the iron in which 3 to 4% carbon is present and very small amount of these impurities is present, that is called as the pig iron. So pig iron is obtained from this blast furnace. And my dear students, if this pig iron is processed again, that can be converted to a cast iron, which is relatively more pure form as compared to the pig iron. So pig iron is the impurest form of iron which is obtained from this blast furnace. And if this pig iron is again mixed with the coke and again this process is carried out, it can be converted to cast iron which contains 2 to 3% carbon. So the output of the blast furnace is the impurest form of the iron, that is the pig iron, which is very hard and very brittle substance. And my dear students, then there are different furnaces which can be used to convert this pig iron into the purest form of iron, that is called as the wrought iron. So our next topic will be how to convert the pig iron into the wrought iron. This was all about this lecture. I hope so that this lecture will be very useful for you people. In case you find any problem, you can ask in the comment section. I will answer that. Till then, take care.